Hello friends, I welcome you in lecture number 24 on higher order ordinary differential equations. In this lecture also we will discuss one more problem on the method of variation of parameters. So let's start with this example. Solve y double dash minus 3y dash plus 2y equal to e raised to x over 1 plus e raised to x. Now as we know, on the right hand side we have division of exponential functions, so we cannot apply shortcut methods as well as method of undetermined coefficients. So this problem we have to do by the method of variation of parameters. So first we start by solving the corresponding homogeneous differential equation. So the corresponding homogeneous ordinary differential equation is y double dash minus 3y dash plus 2y equal to 0. So to solve this equation, first we have to write its auxiliary equation. The auxiliary equation is lambda square minus 3 lambda plus 2 equal to 0. So this we can easily factorize. We rewrite minus 3 lambda as minus 2 lambda minus lambda plus 2 equal to 0. So therefore here we consider lambda common, so we have lambda minus 2 inside the bracket, and from these two terms we consider minus 1 common, so we have lambda minus 2 inside the bracket. Now again we consider lambda minus 2 common, so here we are left with lambda minus 1. So therefore lambda minus 2 equal to 0 and lambda minus 1 equal to 0. So therefore two possible values of lambda are 1 and 2. So we have real and distinct roots. So therefore the complementary function is yc equal to c1 times e raised to x plus c2 times e raised to 2x. So this is the complementary function for given non-homogeneous ordinary differential equation. Now for particular solution we have to first denote these two functions by y1 and y2. So we consider y1 equal to e raised to x and y2 equal to e raised to 2x. Then we have to find out Wronskian of these two functions. So then Wronskian of y1 and y2 is, so Wronskian is given by the determinant with first row as y1 and y2, second row as first order derivatives of y1 and y2. Okay, so this I should write properly. y1 dash, here y1 is e raised to x and y2 is e raised to 2x. So e raised to x, e raised to 2x, here derivative of e raised to x, here derivative of e raised to 2x, which is 2 times e raised to 2x. And to evaluate this determinant we consider cross multiplication. E raised to x times 2 into e raised to 2x, which is 2 into e raised to 3x, minus e raised to x into e raised to 2x, which is e raised to 3x. So this is going to be e raised to 3x. So therefore Wronskian of y1 and y2 is w equal to e raised to 3x. And we have to write what is right hand side of given equation. So it is e raised to x over 1 plus e raised to x. Let me check again. Right hand side is e raised to x over 1 plus e raised to x. Wronskian is e raised to 3x. y1 and y2 are e raised to x and e raised to 2x. So we will require y1, y2, we will require Wronskian, and we will require RHS of given non-homogeneous equation to put into the formula for particular integral. So we have ready-made formula for particular integral. The particular integral is yp equal to minus y1 times inside the integral y2 into right hand side over Wronskian integration with respect to x, and we interchange this y1 and y2 and we consider positive sign r and Wronskian as it is, r and w as it is. In this second term we are replacing y1 and y2 and we consider positive sign here. So now we just put values of all these quantities and we try to find out integral. y1 is e raised to x, y2 is e raised to 2x, Wronskian is e raised to 3x. y2 is e raised to 2x, Wronskian is e raised to 3x, rx is e raised to x over 1 plus e raised to x. Now y2 is e raised to 2x, y1 is e raised to x, Wronskian is e raised to 3x, and right hand side is e raised to x over 1 plus e raised to x integration with respect to x. So now this we can rewrite as, so here we can see e raised to 2x into e raised to x, that is e raised to 3x, that will cancel out with this e raised to 3x. So we have 1 over 1 plus e raised to x dx plus e raised to 2x. Here this is e raised to 3x and these two will be combined to e raised to 2x. So we are having e raised to 2x over e raised to 3x. So this is going to be e raised to minus x. E raised to x into e raised to x, that is e raised to 2x divided by e raised to 3x. So that is e raised to minus x over 1 plus e raised to x dx. Now how to integrate this? So to integrate this first one, this is as it is. To integrate this first integral, we divide numerator and denominator by e raised to x. So if I divide numerator by e raised to x, I have 1 over e raised to x, which is e raised to minus x, and in the denominator I will have 1 plus e raised to x over e raised to x, that is 1 over e raised to x, which is e raised to minus x, plus e raised to x over e raised to x, so plus 1. So we are dividing numerator and denominator by e raised to x plus e raised to 2x as it is. Here also we divide numerator and denominator by e raised to x. We keep this quantity as it is, and same thing we are doing. 1 over 1 plus e raised to x is divided by e raised to minus x. So here also we have e raised to minus x, here e raised to minus x plus 1 dx. So in both the integrals we are dividing numerator and denominators by e raised to x. Now if you observe this quantity e raised to minus x plus 1, then its derivative can be set in the numerator. So here derivative of e raised to minus x plus 1 is minus e raised to minus x, that we can set by taking this negative sign inside the integral. So we rewrite this as e raised to x, and here minus e raised to minus x divided by e raised to minus x plus 1, integral is with respect to x, and plus here in the denominator we have e raised to minus x plus 1, so that we set in the numerator. This we write as e raised to minus x is rewritten as e raised to minus x plus 1 minus 1, and here we keep this as it is, e raised to minus x plus 1 integration with respect to x. Now e raised to x as it is, here this is e raised to minus x plus 1 whose derivative is minus e raised to minus x, which is in the numerator. So we have logarithm of e raised to minus x plus 1. Okay, we are using this formula f dash x over fx has integral log of fx. So here fx is e raised to minus x plus 1, its derivative is minus e raised to minus x, which is in the numerator. So this is equal to logarithm of denominator plus e raised to 2x, and this we can rewrite again as, now we consider e raised to minus x plus 1 divided by e raised to minus x plus 1, which is 1, minus 1 divided by e raised to minus x plus 1, then integral with respect to x. Now we keep this as it is, e raised to x logarithm of e raised to minus x plus 1 plus e raised to 2x, and this again can be rewritten as, we multiply this by e raised to minus x. So we have e raised to minus x minus e raised to minus x over e raised to minus x plus 1 integration with respect to x. So this is as it is, e raised to x logarithm of e raised to minus x plus 1 plus e raised to 2x, and we consider one more step, we rewrite this as integral of e raised to minus x, and we consider negative sign inside the integral. So here we have minus e raised to minus x over e raised to minus x plus 1 dx, so that again derivative of e raised to minus x plus 1 is in the numerator. So that is the reason why we are writing in this way. We consider positive sign here and we consider negative 1 with the multiplication of e raised to minus x. So this is equal to e raised to x logarithm of e raised to minus x plus 1 plus e raised to 2x. Now integral of e raised to minus x is minus e raised to minus x, and the integral of this is logarithm of e raised to minus x plus 1, because derivative of e raised to minus x plus 1 is in the numerator. So value of this integral is logarithm of function in the denominator. So now this is equal to, so now we can rewrite all these things. This is as it is, e raised to x times logarithm of e raised to minus x plus 1. Here we multiply e raised to 2x with this bracket, so we have minus e raised to 2x into e raised to minus x, which is e raised to 2x minus x, and plus e raised to 2x times logarithm of e raised to minus x plus 1. So this is our particular integral, and finally we have to write down the general solution. Therefore the general solution is y equal to complementary function plus particular integral. Therefore y equal to complementary function was c1 e raised to x plus c2 e raised to 2x, and we write down this. We can take this logarithm of e raised to minus x plus 1 common, and we have e raised to x plus e raised to 2x times logarithm of e raised to minus x plus 1 and minus e raised to x, and here c1 and c2 are arbitrary constants. So in this way we can find out general solution using the method of variation of parameters. All we have to remember is this formula, and we have to find out Wronskian of two functions in the complementary function. So this is all about this session. I hope you like it. Thank you very much.